everyone. Welcome to another Bounty episode of the Day Zero podcast. I'm Spectre, with me is Z, and today we have some CSRF and SSRF stuff, an LPE in Pritunl VPN, and a NodeBB 0-day. And before we get started, thanks Belika for the 15 months. Really appreciate it. So we'll get into our first topic here, which is actually request smuggling in Apple. Some Apple domains such as business.apple.com, school, and Maps Connect. Really quick topic to start off with. Apple had the classic request smuggling issue where their front end server would parse the content length header in request for the size of a request and kind of ignore or try to censor out the transfer encoding header. And the back end would end up using that header if you could get it passed. They did have to do some trickery to get that forwarded. They had to inject a new line into that transfer encoding header to get it passed. But
Well, so
yeah,
they
once they
indicate a new line and a space in that header name. So they do that right before the colon in the header.
yeah
But yeah, new line and space. They don't
yeah
really
fair enough.
go into why. It is an interesting case. My guess is just that the front end server was like parsing through, looking for transfer encoded or encoding, planning to remove that so the back end wouldn't parse it. And they kind of had either some fuzzy parsing on the other side. It is interesting that this did still work because even on the back end, you'd kind of expect this to just be like some sort of invalid header. Oh no, it is a weird case when you have like the new line. Well, okay, so actually, I guess that is new line, but not RN. No carriage return. So it is just half of it. So that could be why if they then strip like non-printables or something. Um, that could be related to it.
Yeah, so I was kind of thinking the same thing, but yeah, it's just some kind of synchronization issue between the parsing on the front end and back end, which I guess isn't too surprising since um, the request smuggling's here in the first place. But yeah, so they could use that to smuggle a header using chunked encoding with zero length chunk, kind of standard request smuggling at that point. Once they had that, they created a POC where they would smuggle a GET request to the static docs endpoint, which in this domain's case would redirect using the host header value, which because you could control the headers, you could specify that to go to your server, which would get users redirected there. The impact was a bit higher than just that, though, because they were able to poison the response queue to get random responses sent to unintended users, which is kind of another thing that we've seen before with request smuggling. And since those responses would contain set cookie headers, it's possible to leak data and take over accounts with no user interaction needed. So
Yeah, they kind of
the
did
impact was a bit
that.
higher there than their initial POC. And yeah, go ahead, see.
Yeah, they kind of did that. I think they called in here a Q poisoning attack. I haven't heard it called that name, but we have seen this uh sort of attack before. I want to say it was with like GitHub or something. I don't necessarily know if we covered it, or I think it might have just been covered in like James Kettle's talk about request smuggling at DEF CON last year. Um, but basically, what ends up happening is when you end up sending in a or smuggling in a complete request. So one way you can abuse these request smuggling attacks is to have a partial request and then somebody else's data comes in as like post the post body of it or something. So they complete your request and you just kind of end up with getting access to whatever information was in there in their request. Well, with this sort of attack, what ends up happening is by smuggling in a complete request, all of the following requests end up kind of being out of order. So the front end is kind of seeing like one request comes in, one request comes out. Well, since you sent two requests into the back end, there's going to be two responses coming out, which means the next person coming in, that second response to your smuggled request, that is actually going to go to whoever that user is, and then the response to that legitimate request is actually going to go to whoever like the next user is that comes in, and it's going to keep going on and on and on, and everybody's going to be getting the cookies of the user who made the request, if there's a cookie being set at least, of the user being set, before their request. So it's basically leaking it continually to everybody after and can really screw up with a lot of things. If I remember correctly, it was either GitHub or GitLab where this was done that we last, I think, might have talked about it. Or at least fairly noteworthy attack. So it is interesting to see it here also.
Yeah, I know for a fact we talked about it before, but it's been a long time. Because like I'm trying to think of when the last time we covered request smuggling like this in detail was, and it's been a while.
Well,
So it's kind of cool to revisit it.
I suspect it might have been during one of our summer streams when we were just covering the DEF CON talk.
Yeah, it could have been. That would make
Yes,
sense
we
as in the
watched
timeline in my head.
yeah, we watched that one request smuggling one. So I think it might have been during that. Either way, they went for that route on the attack, obviously leaking a lot of information there. And yeah, got a nice $36,000 bounty out of it. They also kind of have right at the end, they were able to bypass access control rules on this internal directory. As the front end would block it, but the back end would let the request through.
Yeah. So as you said, 12K bounty for each of the domains, which totaled to 36K. So pretty nice payout for the researcher here.
Yeah.
All right. So up next, we have a quote double-edged SSRF that was found in an anonymous website by Yassine Abukar. Apologies if I said that wrong. And I'll let Z get into this topic.
Yeah, and this one, call it double edged largely because it has kind of a client side and a server side impact. Oh, funnily enough, last episode I think was we were covering that PDF cross-site scripting thing. Where he had this cross-site scripting kind of having a server-side impact, if I recall. Or I think that might have been a couple episodes ago. We were covering that, and I was saying, like, okay, PDF export, I mean, it definitely exists in applications, not super common. This is a weird scenario to be in. This one, is again in a PDF exporter. So this time they've got on the API, this API UI export page, format PDF, and they'll actually email it to the user. They provide whatever email parameters, and it just takes in this location parameter, which is supposed to point to whatever endpoint you want to see, and it literally just sends you a screenshot via email of whatever location you're providing it. So what they figured out though is that would also work against authenticated endpoints. So they didn't actually give one of the example authenticated ones, but or that I recall. But just imagine setting the location to your profile information or something. Like you could see what the actual user is. It would basically on the server side perform an authenticated request as your user, and it did that by including a couple of headers. Here the XCH auth API token and email. So basically, request comes in, they look at who made it, add these headers onto it, and they would add those headers without really any consideration for are you actually making a request to one of their own endpoints. So they were able to basically point the location. They did have to use the kind of @ trick to change the domain that's going to, but use that, and when the request would come to your server, you would see these headers being added. So you had the client side impact of being able to leak another user's, and this is hittable with like a CSRF, so you can cause another user to hit the same endpoint. And that would leak their API token and email, meaning you can then use the API as that user also. So that was kind of an interesting aspect of it. But because this was also doing screenshots of the pages, they started looking at the internal pages that they might be able to hit. And I think kind of the crazy one they hit here was this redash, or just kind of a redash subdomain. And what it had was the email and password in plain text auto-saved into the login field. And I'm not exactly sure why, this password field wasn't, type password, or why they're
Yeah, super
auto-filling the
strange.
credentials. But they were, and so you could take a screenshot of this page and get credentials with that. And they
That is
found
utterly
other,
insane that worked. Like,
I
there's just no reason for that to work.
yeah, I mean that's just kind of lucky. I mean, I've seen similar, like I have seen that in some corporate environments where they'll have some proxy that automatically adds in credentials. Not quite like this, but like a similar concept where it would the front or the reverse proxy would basically just fill in some forms for you. Um Not like this, but I've seen a similar thing. So like I could imagine what somebody was thinking with this, but that's not the right way to go about it. Like it is an issue no matter what. Um but yeah, so they had that. They obviously found a lot of other internal API points, but I think this redash login page is just kind of the crazy one.
Yeah, I did want to comment a little bit on how they ended up finding the Redash dashboard and like a link to it, which I thought was kind of cool. Basically, they just did some open source intelligence on GitHub and found like this link or this subdomain being referenced somewhere. I just thought that's kind of cool because we don't really see OSINT being used too much in a lot of these posts, but it was helpful here for discovering that internal endpoint. From there, they were able to discover a bunch of other ones too, like Kibana and whatever. But like Z said, the the Redash one was the most insane one of the bunch for sure, in terms of like the impact and what you could do with it. So
Yeah, and I mean the fact that it's adding those couple headers that can then be exposed to the third party domain, so the attacker's domain, like that does make this also an interesting SSRF. Also, I think it's a somewhat interesting scenario to be in. I mean, adding oftentimes when we see this, it's adding like the server's API token, so it can just kind of do everything and very privileged. In this case, it's like the specific users, which it feels at least a little bit different, a little bit of a different use case. Just interesting to see that one. So I
Malika
did
mentions
find.
and
Oh, go ahead.
I was just gonna say, Blake mentioned in chat. So many companies leak their internal domains and set up addresses. Yeah, I mean that doesn't surprise me too much. I could see it being something that they don't really care that much about. They're like, okay, it's privileged off anyway. Who cares? But when you get into an SSRS like situation like this, that's when it starts to matter. But
I mean,
yeah,
the
like I said, I'm not too
developers,
surprised.
yeah, like generally, a lot of developers kind of know they shouldn't be putting that information out there, but sometimes it's just a lot easier, like Stack Overflow. I once had an entire engagement that was just like find all the information about our internal stuff that you can with OSINT. Like that was the whole thing. It wasn't. There was no. Well, we did have a second part of the engagement with more traditional testing, but a large part of it was just look at the OSINT and find things. And I mean, a lot of developers, it's just maybe they're copying logs out from an error or something, and just things slip through in that way. Either not thinking about or just not caring to clean up because sometimes it's like you'll see the host name in a terminal prompt, and you only see the host, like the first part of the host name, not the entire host, so you can't necessarily associate with the company, but other information gives that away. There's a lot of ways it leaks. Like, I mean, there's a lot of questions on Stack Overflow that leak internal information. Um, yeah, I mean, it shouldn't happen. Like you said, I think a lot of people look at it as, this is privileged off anyhow. Like, who cares if they know about it? They can probably figure it out some other way, which is also true. It would be a hard thing to completely prevent. I mean, copying logs out or something can just be a little bit easier. There are some things on that, but it does feel like one of those kind of low hanging fruit. Doesn't feel like a huge issue. It's just useful to the attacker, but isn't itself an issue, so gets looked over.
Yeah. Sorry, was there something you were gonna say before I interjected with that? It sounded like there was, but
Oh, I was just going to say, and that's why I liked this SSRF because of that client side impact too. I didn't have anything substantial to say.
oh, fair enough. All right, cool. So we'll get into an LPE through the pre-tunnel client. So this was documented by Rhino Security Labs. Um, this was a arbitrary file write as system and path bug in pre-tunnel VPN, which is mostly an enterprise VPN for connecting cloud environments with site-to-site links and remote user access and stuff like that. And it wraps around OpenVPN, which is a pretty common and well-known client. Um, the arbitrary file write happens through the OpenVPN profile, which gets created when by importing a config into Pritunl. And OpenVPN will get ran and use that profile as system. They do try to sanitize the configuration file of any dangerous OpenVPN directives when importing it, but an attacker can just overwrite the VPN file directly anyway. So um,
Well,
now,
kind of.
like,
So it sounded like said the arbitrary write happened with that, and that's not quite true. Um,
well, no, it happens a little bit later,
yeah,
but
okay.
I was about to get
I'll
into
let
that.
you keep going.
Okay. I did also want to mention before getting into that though that Pretunnel also does set the security script one flag. So even though you could use some of the dangerous open VPN directives, you can't execute external commands directly. Like it's not that easy to privesc. But you can use the log directive for specifying an output path for logging output, and you can specify this path to whatever you want. Now you don't control the full contents that get written out, but it is pretty easy to get controlled content in the log through like credentials or whatever. So that kind of gives you this arbitrary right or semi-arbitrary right, I guess, since you don't fully control the contents, um, which you could use to write into the pre-tunnel VPN program files. And they kind of chain this with another bug, which is the fact that OpenVPN will use ipconfig to try to get some network information when it runs, but it invokes ipconfig without using the absolute path, which is kind of a common issue we used to cover quite a bit, though we haven't done a little while. And the reason that's a problem for those not aware with how Windows works when it searches for executables to run is it follows this certain hierarchy for looking for an executable, and one of the first places it'll look is in the immediate folder before it'll look in any of the system paths. So if you just call ipconfig and don't call it with the absolute path to the system ipconfig, if one is already present in the directory, it'll execute that. That'll kind of take precedence. So by using the arbitrary right to write the ipconfig batch file into the pre-tunnel program files, they can take advantage of this other issue where it'll end up running the your fake ipconfig instead of the real one, and then obviously you have execution as system, which is a pretty big prevesc. So yeah, kind of a two-part attack there, but the arbitrary file write is really what allows it to be taken advantage of.
Yeah, I mean, arbitrary file write tends to be a pretty powerful primitive to have when we're talking about having our file write as system. Um, there was that little bit of a race on it, so you're talking about the program data file. So the usual flow, you import a configuration that goes into your app data folder. Um, and then when you actually want to run or connect with it, it then copies it, sanitizes it into the program data directory, and then executes OpenVPN. So that's where you can start trying to overwrite it. You do only have a short window of time to actually overwrite it, because it's going to write its file and then execute OpenVPN. So you kind of get it in between that moment. So there is a little bit of a race there, but you just shouldn't let that be written to in general by like any user. Um, Maybe would have been better if they put that in their program files rather than program data. Um, but yeah, that's just one detail I think you kind of skipped over. It was a race to overwrite it.
Yeah, so they had a demo like GIF or whatever in the post where they were showing like connecting and how they might have to do it a few times to kind of get that race to work. So yeah, it's worth calling out for sure. And I did kind of skip over it, but um, there's multiple issues here that allowed this chain to work. Um, Even though the title only indicates there's like that one file write bug, there's like three issues here that I could count that allow this attack to take place. So
Well, the title
yeah,
is just local privilege escalation, so that kind of it's the whole chain to do that.
yeah, fair enough. All right, so we'll get into our last topic here, which is a bug in NodeBB, and I'll let Z take this one away as well.
And just adding on the last one, Blika mentions you can just write a system wrapper DLL in the folder and on the next start the deal will run. Yeah, I mean with the system, right, there are other ways that you can exploit it. This one in particular, they went ahead and targeted just the uh just the config, or basically just what's going to be present for this one, not requiring the whole reboot and stuff. But I mean, it's fair to call out because yeah, there's like I said, arbitrary system is a very powerful primitive to arbitrary right as system is a very powerful primitive on Windows. Well, on anything. All right, so jumping back to the NodeBB bug, um, this one was kind of an interesting way of abusing single sign-on, where what I'd say the root of this one is the fact they're not really using. Sometimes you'll see a state variable being passed around. Um, Effectively, by not using that, it becomes C-surfable, which then creates a situation where a user can trick another user into linking the basically the wrong account with their account. Jump back. The whole attack here basically comes down. You have your attacker account. They go through the normal SSO sign-in process of, or not sign-in, but the linking process. So presumably you have an account and you're linking like Google or something to it. And when you get the callback coming through, which actually contains that authorization code, um, basically intercept that request so it doesn't actually hit the server and it's not going to associate that with you. So if you then get another user to make that request, so standard CSRF thing, it's just the gets, you can maybe put in image or something on a random site, get a user to visit, then the application, in this case Opera's forms, will see that callback code and just look like, hey, what account is currently logged in? Okay, let's check what Google account this is and basically associate the accounts that way. You're basically tricking it by not completing that request. Had they used the state token here, that would have been at least one way to detect this because that state shouldn't have been predictable. Um, I don't know. I thought this was an interesting attack. I don't think we've covered it. I mean, it's not a new attack. This isn't a novel way of abusing SSO. I just don't think we've covered any scenario like this on the podcast before.
I think we've seen similar, like very similar cases with codes used in other contexts, like maybe
Well,
I
like
want to
we've
say like
seen
maybe
issues
password
with
reset type
code,
stuff.
code in general. Yeah.
Yeah, like I can think of similar scenarios, but not exactly this one with single sign-on. I think you're right.
Yeah, I thought it was interesting to see, largely because I thought, using state was a pretty well accepted practice at this point. Um, you provide a state, it sends a state back with the code, validate state before you actually go on with the code. Um, so it surprises me that they were vulnerable to this, but yeah, I mean it's a straightforward attack. It's kind of what you can do if you're abusing the lack of state or basically C surfability here. And fairly straightforward.
There's a bit of interesting background here with the bug as well, because NodeBB was informed of this issue previously in their bounty program in June of 2018, and it seems it was already fixed once before. I don't think they link to the report, do they? No. So I don't think we really have many issues on that. They just kind of say like it was reported. But then in early 2021, they had some kind of refactor which reintroduced this bug. So the bug was fixed, or it was reported years ago, and then it was fixed, and then it was reintroduced again, and now it's been fixed again. So a little bit of an interesting history there. Unfortunately, I don't think we really have many of the details, but
I mean, I think we have enough of the details, I guess. I guess we could have gone surfing to go find the actual patch that removed it or it reintroduced the bug, which might have been interesting to do, but I mean, the fundamental details are there about the attack at least.
yeah. And Balik kind of mentions a kind of a funny scenario where a same developer looked at it and said, "What is this? Let me put back my old code." Like, yeah, could have been a situation like that. It'd be pretty funny, but Yeah, I'd be a little bit curious. I kind of wish we did commit surf it a little bit, just because I'd be curious how they fix it the first time and then how they would have reverted that. It seems like something that you would kind of want to keep in mind in a refactor, but you know, uh, what do I know? I
Yeah,
guess.
I mean, again, it really depends on how they did the fix. Like I said, I keep referring to the state. They might have been checking something else. There are some other ways it could be done. So I mean, maybe they just well, yeah, I don't really want to speculate too much without seeing the code. So I'll just say it happened.
Yeah, there we go. We'll leave it at that. All right, so that's all the topics that we have for this episode. So I guess we'll wrap it up there. Thank you everyone who tuned in. The VOD will be up on YouTube and Spotify and other platforms tomorrow. Remember to check out our Discord and follow us on Twitter. Links for those are on our site or in the chat. And we'll hope to see you again in the binary episode tomorrow, which is at 7 p.m. Eastern, 4 p.m. Pacific. We'll see you then.